So this is midterm 2B, fall 18, problem number 3. And it says given surface density sigma equals 1.8 E naught and electric field E1 in air, find E2. This is going to be E2. The boundary condition is defined by the inclined plane parallel to the z-axis as shown. So we will be using these two equations, and this equation can be also written here. And then we would want to define our normal vector and our tangent vector. So the normal vector has to be perpendicular to the boundary or the medium and going away from it. So this is going to be our normal vector. And we can either choose our tangent vector to be either going up or going down. But here we're going to just choose going up because we know that this 53-degree angle is going to help us get by drawing a parallel line plane here, or line here. This angle is going to be 53 degrees, and this will also be 53 degrees. So since we know that the boundary is defined by the inclined plane parallel to the z-axis, we know that the E1z and E2z is just going to be equal to 4, the same right here. And then drawing the normal vector again, right here, using 53 degrees, we can define our x and y component for the normal vector, and drawing our tangent up, which is this one over here, using this angle 53, we could also find x and y component for tangent vector. So solving for our n hat and t hat, you can see that x component is cosine 53, so cosine adjacent over hypotenuse, and then our sine 53 is going to be the y component, so opposite over hypotenuse. Simplify to that. Same for t hat. Since it's in, this is our t hat, it's going to be negative x, so this is negative, that's why it's this way. So sine 53 degrees, opposite over hypotenuse, and then it's negative, so negative in the x hat, and then y hat is going to be adjacent over hypotenuse, so cosine 53, and it simplifies to that. So now we want to solve for E2t, and to do that we need to find E1t because of this equation. So our E1 is given, and then we solved for our t. So E1 dot t is just going to become a scalar. So this 2 is from the E1, same with this negative 3. And then since in our t hat there's no z direction, that's why it's 0 here. And then this is from our t hat, so this is right there. This is this one. Solving it, we get negative 3.4 for E1t, and since E1t equals E2t, E2t also equals negative 3.14. So we're going to do the same for E1n, so E1 dot n hat equals negative 1.2. And then using this equation, we want to solve for d2n, which gets us to here. So d2n equals d1n minus sigma, which we can also expand it to this equation. So replacing sigma with 1.8 E naught given, which is given, and then replacing the E1n with this, since it's E1n here, so negative 1.2. Since E1 is in air, this would go to 1. So we're left with this, which simplifies to negative 3 E naught. And then plugging in for D2n, since we have E2 given 1.5 E naught times E2n equals to D1n n minus sigma, which is this, negative 3 E naught. Solving for E2n, we get negative 2. So, finding E2, the total, so you would combine all the terms. So E2n is negative 2 times the n hat, and then E2t is negative 3.4 times the t hat, and since we had 4 from over here, so that's this 4 times that z hat, and then simplifying, we would get this, and that's your answer.